Actual calculus stuff. Kind of couple updates. First, I know Cassie asked about the AP exam. Right now, we're kind of seeing everything from it's not going to get canceled at all to it's going to be take home. I haven't seen anything about them canceling it. I did see that they'll allow schools to apply for a later date. I don't think we would qualify that since we've been teaching. So as of right now, we need to just plan like our exam's going to be on the same date, which is I believe it's May 4th or 5th. I got to look at it, but it's that first week in May. Yeah, May 5th. So that's what we need to plan for. We're at a much better pace than a lot of other schools. One school that I actually talked to them there in Indiana because they've been doing this e-learning stuff for a couple weeks before us, and they wanted to. Mr. Leandro wanted me to like reach out and help the teachers set that up if we need to. That guy, they're still teaching at their school. They're on area and volume, so we're in a much better spot than they are. So if we have it on the 5th for our class, we'll be fine. I'm confident we could even do this setup, until after spring break and come back and be fine for the AP exam. Or worst case scenario, if it even goes further than that, we would still be fine. One thing though that I do want us to try tomorrow is it's called Zoom, and that's because if this right now it's initially it was like the first 2 weeks, right, where they said we're gonna be closed for 2 weeks, and now it looks like we're gonna be closed the third week until spring break, and so the admin wants us to be able to. Right now, only the seniors have been like having new material; all the other students haven't. But the admin wants everyone to have new material, so they're asking me to kind of pilot it to like test it out. So they want to use Zoom. It's basically just like Google Hangouts or Google Meet. It's just you can download it app from the App Store, or you can use your computer. But tonight, kind of before tomorrow's session, we'll download that because tomorrow, instead of doing Google Meets, we're going to use Zoom. And then they're going to try to have like a special device for the teachers to be able to write on nicer, called a Wacom tablet. I think some of you guys use it if you've taken Miss Fury's class. So that's what we're going to try tomorrow. Okay? Sound good? So, I know it's kind of a little bit nervous. I definitely agree with Cassie where it's like you're feeling overwhelmed if school's out longer and then we still have an AP exam. But I want to promise you guys we're right on track. If you guys just keep doing the homeworks, you'll be fine. And if you need to post a comment on your homeworks, right, just like add a private comment, hey, Miss Viewer, I totally couldn't figure out 2C. Do that. If you want to just post it right in Google Classroom for everyone so other people can see it if they were confused on that same one, do it. It'll help everyone out. Alright, so today we're going over, and I'm just going to kind of give you a look at it. So today's lesson is on these, it's basically the title's like function analysis or graphs of f prime. But this is essentially what we're looking at. Usually these are no calculator questions. Actually almost always these are non-calculator questions, where they're giving you a graph of f, and really they say g of x is equal to the integral. So really this is the graph of g prime. Sometimes they'll just state that it's the graph of f prime. So that's what we're going to be looking at. I will post this for you guys, but this is essentially going over all of our stuff from first derivatives and second derivatives. So what I want to kind of do is, here we go. Okay. So we're going to look at what is it asking us for. By possible entry, I mean like basically what do we need to write down before we can actually justify or look at this. And then right now I have it as explain your reasoning given f of x. But we might switch that as well. So if we have a critical point, right, critical points are just when f prime equals 0 or undefined. Right, on a graph, that's either this horizontal tangent is when f prime is 0, or any kind of discontinuity, right, kink, corner, etc. is dne. Relative maximum, same thing, but now we need to justify it by just saying f prime changed signs from positive to negative. You'd also justify it saying f changed from increasing to decreasing. Relative min, same thing, just the opposite way. Increasing, same point of entry, f prime of x equals 0 dne, and then it's when f prime of x is greater than 0, right, or you could say f prime of x is positive. Decreasing, same thing, but negative. So really all of these here, these are all talking about, or we're looking at f prime. And then, oh, I went that too far. To here. Right, and then these bottom ones, these bottom three are talking about f double prime. So, point of inflection, right, we take f double prime equal to 0 or dne, and then it's when it changes signs. So this one's a little bit different, right? It's only a point of inflection if f double prime changes signs. If f double prime doesn't change signs, it's not a point of inflection. And then concave up, when f double prime is greater than 0, positive, concave down when f double prime is less than 0. This should be pretty much review for all of us, but it's just worth going over. Now, one thing before we actually start is that these usually are the graphs of g prime, right, not of f. So if we're thinking about g prime, what we want to think about is that here, if we're given the graph, right, we want to know increasing matches up with f prime positive. So if we have the graph of f prime, it's when that graph is above the x-axis. If we want a maximum, it's when the graph changes from positive to negative. Whereas down here with concave up, concave down, these are a little bit different because if I have the graph of f prime, then what f prime kind of matches up with f double prime is when f prime is increasing, that graph of f prime is increasing, then f double prime was positive. Or f double prime is positive. So if I want to know when is f concave up, but I have a graph of f prime, then it's when is that graph of f prime increasing. If I wanted an inflection point, then it would be when it changes between increasing and decreasing, when f prime changes. So we're going to just jump right into this. It's really kind of short on the notes today because this is something we spent a lot of time on, and I'd rather just kind of go through examples. So the first one is from 2014. Like I said, these are all non-calculated questions. And before we really do anything, and one thing I haven't mentioned this before, but on your AP exam, in the booklet, if you write anything up here, at all, like anything up on the graph in this area, it's not graded. Okay? Even anything right here, it's not graded. They're only going to grade things in the space that they give you. So there's going to be a box for A, and all of your work needs to go into that box. So if you're writing any notes to yourself up here, like let's say you said, oh, we need to set G equal to 0, then if this was worth 1 point for setting G equal to 0, you're not going to get that point unless it went down here. So make sure when we're writing that you're kind of practicing that, especially if you print these out. So anyways, one thing that I do before I do anything else, and I usually do in part A, is that they gave us g of x equals this integral. Now, we might use that, but we're definitely going to also have to be thinking about that what is g prime of x and what is g double prime of x. So I like to just write these down just so we have them, because they didn't give us, they only gave us g of x. So to get g prime of x, we take the derivative, right? That's that second fundamental theorem of calculus, where we plug in x and then we do the chain rule. So if we plug in x, we get f of x. And then technically it's times 1 because of the chain rule. You don't need to write that times 1, but just remember that if it was 2x, then it's times 2. And so g double prime of x, if we take the derivative of f of x, gives us f prime of x. So that's just something that we want to make sure we're aware of. And I do that before I do anything else on this question. Now, A says find g of 3. So we don't care about g prime, we don't care about g double prime, it wants g of 3. So I wrote these two down, we're going to just save them for later. So for g of 3, right, g is equal to this integral. So we can write this as g of 3 equals the integral from negative 3 to positive 3 of f of t dt. And so negative 3 is starting up here on the graph, and we're going from negative 3 to positive 3. Ooh, it's not liking me writing on this. So that's 2, that's 3. So it's going from negative 3 to positive 3. So it wants the area between starting at negative 3 and ending at positive 3. I did see some of us draw these incorrectly. Make sure you're drawing it from the graph straight to the curve. So this is one big triangle that's above the axis, so it's positive. And then this is a second smaller triangle, so it's below the axis, it's negative. And then again, same thing. If you want to make sure you're getting points, don't put your work up here with the graph. Make sure you put it down here in part A. So those are both triangles, so we're going to write that this is equal to 1/2. And then the base of that top triangle is 5. And the height of that top triangle is 4. And then plus that bottom triangle. Now, actually, this is where you can get a little bit confused, because you can either do plus and then make the height negative, or you can do minus because it's below the axis. I'm going to just do minus since it's below the axis. I'm going to put minus 1/2. The base of that smaller triangle is 1, and the height of that smaller triangle is 2. Right, so what we did was, that first triangle had a base of 5 across, and 4 up. I did this whole big triangle. You could have split into the left side and the right side. And this bottom triangle had a base of 1 and a height of 2, and I made it negative because it was below. So, then you're just going to multiply the 2's cancel, so we get 10, minus these 2's cancel, 1, and then we get 9. So, questions like this, if you box your answer, that can help the grader to just kind of stay organized when they're reading it. Alright, question B. Actually, you guys asked me to go a little slower, so I'll give you a second or two if you want to copy that down. So while we're doing that, I'll read through B. B says, when is the graph both increasing and concave down? So, when is it increasing and concave down? So, I'm going to just actually, see if we can do this. So we're going to want to just have that same, what we wrote was g prime of x was equal to f of x, and g double prime of x is equal to f prime of x. So we want, when is the graph of g increasing and concave down? So with g, right, g we're connecting, increasing would be when g prime is positive, and concave down would be when g double prime is negative. But when we explain these, we need to make sure that we explain them based on what we have. So we can say that, now we want when it's both of these at the same time. Not like, when is it just increasing, when is it just concave down, but when is it both at the same time, increasing and concave down. So increasing would be g prime positive. So based on our graph, it would be when f of x is positive. Concave down is when g double prime is negative. So based on our graph, it would be when f prime is negative. That means when f is decreasing, right? F prime, right? If we want f prime negative, what that means about f is that f was decreasing, right? If we come back here, it's kind of working backwards, right? I want to know when is f prime negative. That tells me when f was decreasing. We could also go here where I said f prime is increasing, right? The opposite one of that is f prime is decreasing, right? So f prime decreasing would similarly match up with f concave down. So when we come back here, we want to know when is this graph here both positive above the axis, because that's going to give us G prime increasing, or G prime positive, and when either F prime is negative or F is decreasing. So if we're just talking about F, we're saying where is F decreasing and where is it above the axis. So we want those two things, decreasing and above the axis. So that's between -5 and -3, it's decreasing above the axis. And then from 0 to 2, it's decreasing above the axis. If you kind of want to, like a cheat sheet on these, kind of what will always be happening is that if I want to know where is G increasing, G is increasing when F is above the axis. So it'd be decreasing when F is below. And then similarly, G would be concave up when F is increasing, and concave down when F is decreasing. So anytime they give you this setup, it's always going to just be that pattern. So for us, we said we highlighted those two. So the big thing that you need to make sure you're writing down, I'll kind of do my work that I would write down in red, is you want to write down for the greater that you know that G prime of X was equal to F of X. You're showing them that you just connected our graph of G prime to, or our function G prime to the graph that was given, right? They only gave us F of X. They didn't give us anything about G. So that's what we're going to say first, and then we can say that G is increasing and concave down over -5 less than X less than 3, and 0 less than X less than 2, because G prime of X, which was equal to F of X, is, what do we say, positive and decreasing. So it's positive and decreasing over those intervals. While you guys are copying this down, one thing I was kind of thinking of this morning, and it was a little bit too late to do this, but for tomorrow's session, would it be helpful if I gave you guys, like, the files of these beforehand, so that either you guys could print them or at least just look at them? Is that something you guys would want? Okay. Alright, so for part C, in D, now it's no longer talking about G of X directly, but they're still going back to G of X, but they're now talking about new functions, so H of X and P of X. This is a time, too, where I have seen L'Hopital's rule come up. It did not come up in this one, but the last couple years, they've stressed L'Hopital's rule a little bit more. So that's something where they might ask you to take the limit, and if they ask you to take the limit, in your mind, think, hey, they might be doing a L'Hopital's rule here. So now they give us H of X equals G of X over 5X, and they want H prime of 3. So this is really just more a quotient rule question. They're saying, can we apply quotient rule, but then can we also check it on our graph? So before we ever do, we're going to have quotient rule, and that's going to be low D high. So low D high is just G prime of X, and then minus high D low is derivative 5X is 5, all over 5X squared. And remember that we need to square both the 5 and the X squared. I'm actually going to leave it unsimplified and just do the squaring later. So, we could do 25X squared, but I'm going to just leave it for later. So, now we get H prime of 3 equals, and that's 5 times 3 is 15, and G prime of 3 minus G of 3 times 5, all over 15 squared. And this was non-calculator, so you would need to do 15 squared kind of off to the side by hand, or you could have squared it and done 25 times X squared, so 25 times 9 off on the side. Either way, you got to do a little bit of math on your own. And then we have H prime of 3 equals, so now, when we get this G prime of 3, it's not necessarily the slope of the graph, right? Even though we normally think of G prime as being the slope, we want to be extra careful because in this question, this is the graph of F, not the graph of G. So the biggest mistake that students make is that they go to 3 and they take the slope. The problem is it's not. Remember, up here we define G prime of X as just F of X. So really G prime of 3 is just F of 3. So that's just the Y value at 3. So at 3, our Y value is -2. So that's going to be 15 times -2 minus, and then G of 3 is the integral. But what's very common on the AP exam is that was part A or part B. So we don't have to retake the integral, we already have it from part A, we have it as 9. One thing that does happen, let's say you totally just blank and are messing up on part A, write an answer, because if you get part A wrong, let's say you messed it up and you just picked 4, right? You did some work and you got 4. Down here, when you need it, if you didn't do part A, you can't get it right. But if you use that 4 that you had that was wrong, they're not going to double penalize you. So you're going to lose the point on A, but they'll give you the point on C because you used what you thought was the right answer. So anyways, we had 9 from part A, so 9 times 5, all over 15 squared is 225. Alright, and then that's going to give us equal to -30 minus 45, all over 225. And honestly, I might just leave my answer like that. The AP exam, they're not looking for you to simplify it fully. If you want to, make it a little easier on them, -75 over 225. This will simplify. It does simplify to -1/3, but it's a waste of our time to do that. And it's something where we could just make a silly mistake, so I would leave it there. So again, that's kind of just quotient rule. I'll give you guys 10 seconds to copy anything down. Alright, so last one is part D. And part D, they gave us the function p of x is equal to f of x squared minus x. And they want us to find the slope of the line tangent to this graph. So when we see the slope of the line tangent to the graph, right, that just means same slope, right? Tangent just means same slope. So when x is equal to negative 1. So really all they're asking for is, this is another way of them asking for p prime of negative 1. It looks to me like they didn't want to ask it the same way. They just wanted to make sure that you know that the slope of the line tangent means the same as p prime of negative 1. So C was quotient rule, D is chain rule. So we want to find first p prime of x, right? And so whenever we have f of something else, right, instead of f of x, it's kind of like that f of box, right? So we're going to first do f prime of, whatever's inside that box. So f prime of, right, kind of like our box, and then times the derivative of the box. So in this case, that's going to be f prime of, we're going to leave it alone, x squared minus x, and times, now this is very important, what I've seen a lot of people do, and this is totally wrong, is they'll just write times 2x minus 1. This is wrong, and you'll get a wrong answer, because PEMDAS is going to happen, and it's only going to multiply by the 2x. So we need to make sure that we're putting that in parentheses. If it helps you, just put it in parentheses up there, and always put it in parentheses, even if it's just one term. So that's what we kind of need to be seeing. And the AP readers will mark this question wrong. It was 2 points on this exam. You got 2 points for this line here. And if you don't include that parentheses, you're going to be missing out on those points. So next, now we want to plug in p prime of negative 1. So it's f prime of negative 1 squared is positive 1, right? And then 1, so it's positive 1 minus the negative 1 will become 2. And then times, 2 times negative 1 is negative 2 minus 1. So we're going to end up with 3 there. So this is going to be asking us for f prime of positive 2, right? 1 minus negative 1 times 3. Now, f prime of 2, this is asking for f, and we were given the graph of f. So this literally is asking us for the slope, right? It's no longer talking about g, we have the graph of f. So it wants the slope at 2. So the slope at 2, don't worry about counting this point. What you want to think is this is part of this entire line. So I like to use the endpoints. So the endpoints here are at, there is 0, 4, and they already gave us 4, negative 4. So somewhere off on the side, you can just kind of write that we know that f prime of 2 would be equal to, because it's part of that entire line, the whole line is going to have the same slope. So it's going to be negative 4 minus 4, y2 minus y1 over 4 minus 0, x2 minus x1. That's negative 8 over 4, which is negative 2. So I'm coming back over here, right, f prime of 2 we said was negative 2 times 3. Negative, I messed this up. Yeah, thank you, Cassie. So negative, this should have been negative 3, right? Negative 2 minus 1 is negative 3. Negative 2 times negative 3, and we'll get the answer of positive 6. So, this is one example where they did do quotient rule and chain rule, which they can definitely ask with this. The next one is going to do a little bit differently, and they're going to ask some different stuff. So let's jump into that one. So this one, instead of giving you guys that setup of g of x equals the integral of f of t dt, like the last one did, this one just came right out and they just said that this is the graph of f prime. Now, it works the same way as the previous example. Everything basically works identically, except that instead of giving you that graph, right, or that like integral, they're going to instead give us a starting point. So they're going to give us f of negative 2 equals 7, so that we can actually help take this integral. So if you kind of want to write out that general formula that we were doing with the rate of change, right, when we were doing the rate of change, that general formula would be that f of any value x, or any value t, so f at some time t, is equal to, now they gave us a starting point of negative 2, so it's basically we're going between any time t and starting at negative 2. So our starting value is 7, plus the integral from, our start is not 0, but it's negative 2. And so, remember that kind of it's, what it would look like is f of t equals f of negative 2, plus the integral, and the negative 2 goes in the start in the bottom endpoint, and the t goes in the top endpoint, and this is of f prime of x dx. Right, or we could change the t's and the x's if we wanted to. So, what that ends up giving us is that, actually I'll do that, we'll change our x's. So, f of any x is equal to 7 plus negative 2 to some x value of f prime of t dt. So this is kind of, they didn't give us this equation, but this is kind of the equation that we want to make sure that we understand and we can get to, right? So this is essentially the version of what they provided us back here. This g of x equals the integral, right? That's the version that they're giving us here. But they're basically making sure that we can write it on our own. So that happens because we're starting with f prime. To get back to f prime, we need to take an integral. But remember, integral just means change. We don't know what we started with. So we need to figure out what did we start with. Now in this case, really since they didn't give us a starting value, what they're just basically saying is essentially that g of negative 3 our starting value is 0, right? And that makes sense because if we did try to do g of negative 3 with the integral formula, it would be from negative 3 to negative 3. The endpoints would be the same, which we learned was always 0. So they kind of gave us a starting value by just not having any plus there. So anyways, back to this question. So they want us to find f of negative 6 and f of 5. So in this case, right, for f of negative 6, we're going to just write that this is equal to 7 plus our integral from negative 2 to negative 6 of f of t dt. If you put f of x dx, you're going to get the points. It really doesn't matter. This needs to be f prime. Right, f prime of t dt or f prime of x dx. So, and that makes sense because that's the graph we have. So, the key here, if you're confused, like, Mr. Weaver, I'm still not getting the integral thing, is just look at, they gave us f of negative 2, that needs to be one of our 2 points. And then we want f of negative 6, that needs to be our other 2 of the 2 points. And this integral is only ever going to give us the change, so we need to add on the starting point. If you really, really wanted to, another way that I've seen people do this is to just say, I just want to start with that integral. So the integral of negative 2 to negative 6 of f prime of x dx would equal f of negative 6 minus f of negative 2. Right? And that's something, that is our fundamental theorem of calculus. Right? So now if we just added that, like plugged in for f of negative 2, we just plug in 7 and add it over, we get back to our formula that we had. So whichever way you get it, you need to get to there. So now, in order to solve this integral, we need to, on a graph, to solve an integral, we need to do the area under the curve. So it's from negative 2 to negative 6. Now, we do want to be careful with this, because when we start off at negative 2, and we go backwards to negative 6, it always flips our sign. Right? Whenever we're going right to left on an integral, it's going to go backwards, so anything above will become negative, and vice versa, if we had anything below, it would become positive. So, just being careful with that. So that's a triangle. So we're going to write that this is equal to 7, and now minus, because it was flipped, right? Because we're going right to left. So minus 1/2, the base of that triangle was 4, and the height of that triangle is 2, right? Negative 6 comma 2. So our 2's cancel, and we get 7 minus 4, so we get that f of negative 6 was equal to 3. Okay, now we're going to do the same thing, but with 5. So f of 5 equals 7 plus the integral from negative 2 to 5 of f prime of t dt, or again, if you use x's, that's okay. And now, on our graph from, I'll use another color, from negative 2 to 5, we're going left to right normal, so it's just going to be the normal way we do it. Below the curve is negative, above is positive. So this is a semicircle, right? And anytime we have a semicircle, we need to pick out the radius, right? So the radius is just the halfway mark, which is 2. And we also have a triangle with a base of 3 and a height of 2. So let's come over here. So this is equal to 7. Now minus for the semicircle because it's below the axis. So semicircle would be 1/2 pi r squared. So the radius was 2. And plus 1/2, and the base of that triangle was 3, and the height was 2. And so our 2's will cancel out. In this case, 2 squared is 4. And that second, the squared, I don't want you guys to do that because that doesn't normally work. So 4 divided by 2 is 2. So we get 7 minus 2 pi plus 3. And then just add your like terms, 7 and positive 3 gives us 10 minus 2 pi. And so our answer will look like that. Right, it's a non-calculated question. You're not trying to plug in for pi or anything. We just leave it just like that. Okay, B, when is f increasing? So in this case, we don't need to write that whole g of x equals f prime of x thing because there is no g of x. It's all talking about f. So we just are concerned with f increasing. And remember that for us, f increasing means that f prime is positive. Right, so if we kind of were thinking of that cheat sheet, it's really the same thing since we have the graph of f prime. Right, f increasing would be that our graph f prime is positive. F decreasing would be that our graph f prime is negative. F concave up would be that our graph f prime is increasing. So the graph is literally moving up. And f concave down would mean that the graph is decreasing, so the graph is literally moving down. In this case, they only wanted f prime positive, so they just, or f increasing, so they just want where is the graph positive. So we would say that f is increasing over negative 6 to negative 2 union 2 to 5 because f prime of x was greater than 0. You could have just written positive over these intervals. Right, so they don't care if it's going up or down, they just care it's above the axis, and it's above the axis that whole time. Some graders will make this one a bracket, just because, and actually I think that is correct to make that one a bracket, because the reason we make the other ones parentheses is that they're touching 0, right? Like at negative 2 it's hitting 0, at positive 2 it's hitting 0, at positive 5 it's hitting 0, so it's technically not increasing there. But at negative 6 it is positive, so it is increasing there, so that's why giving this a bracket is probably a little bit better. I don't think they're going to dock you for that. Like, if you just left it as parentheses, you should get the point. Alright.
How would you know when to use that format? as opposed to writing -6 is
Oh,
less than 1.
yeah, writing this, -6 less than, technically less than or equal to x, in this case if we're thinking in the bracket, and 2 is less than x less than 5. I think the answer key actually did use this. It doesn't matter, they're the same. So this is the same as this. If you write it either way, you get the points. So it's really up to your preference. I wrote it this way when I was doing it, so that I could have written it both different ways. I wanted to make that point, and I forgot to. So thank you for reminding, or like catching that. So it's, in long word, like basically short story, is that whichever way you like to write it, you write it that way, and you'll get the points, because they mean the same thing. A lot of people like to write this just because they get less confused with, like, if you have 3, 5, is that an interval or is that an x and a y coordinate? So they'll just always write it with the less than or greater than symbols. Some people just like to write it this way because it's a little bit quicker, but it's your choice. Okay. Part C, find the absolute minimum. Right, so absolute minimum, as soon as we see that, and especially we see minimum with interval, we need to think critical points and endpoints. So you're always going to get a point just for basically writing out, anytime we have a minimum, what is it, the minimum of f? So whatever you're taking the minimum of, take that derivative and set it to 0, that's always 1 point. Right, I know on one of the homeworks, it was kind of a mean question, they wanted the minimum rate, and usually when we have a rate it already was the derivative, but they want the minimum rate, so we're taking r prime and setting it equal to 0, because you're doing the derivative of whatever it wants the minimum for. So in this case, we want the minimum of f prime of x, so we're going to take f prime of x and equal that to 0. So in our graph, this graph was already the graph of f prime. So we just need to pick out the zeros. So the zeros, now, technically 5 is a 0. Why am I not so concerned about 5? What do we think? Why am I not so concerned about 5? Someone post it in the chat or just jump on. Yeah, so Cassie said it's an endpoint. So whenever we're looking at this, the endpoints already are included, so they don't really count as critical points. So we get x equals -2 and +2. If you also wrote 5, that's okay. They're not going to dock you. Yeah, that's fine. And so then we're going to make an x and f of x table because we want the minimum of f, right? Whatever we want the minimum of, that goes into our table. So we're going to do our endpoints, -6, -2, +2, and 5. And in part A, we already did -6 and 5, right? We already found that f of -6 was 3, and f of 5 was 10 minus 2 pi. So we can plug these in here. So 3 and 10 minus 2 pi. And then for -2 and +2, we're just going to have to actually do the work. So f of -2 is going to be that same formula, 7 plus our integral from, it was -2, right? Yeah, our integral from -2 to -2. And if you were smart about this, I was not. You would realize that you don't even have to do this one, because they gave it to us in the question, right? But if we did do it, this whole integral goes to 0, and so we just get 7. It goes to 0 because the endpoints are the same. But if you were smarter than me, you'd have realized that they gave us f of -2 equals 7. Right, so really the only integral, the new integral we have to do is f of +2. So now, f of +2 is 7 plus our integral from -2 to +2 of f prime of x dx. And +2 is just where that semicircle ends, right? It's the beginning and the ending of the semicircle. So what this is, and we already did the work, so if you want to kind of use your work from A, you can realize that it's essentially just this portion here, which was just 7 minus 2 pi. So we kind of already did that work, so I'm going to just use that. You don't have to show your new work here, you can just write that, and because we know that we did that, it's 7 minus 2 pi. Now, in terms of actually figuring out that minimum, is we want to think, what is 2 pi, right? And just kind of approximate, right? Pi is about 6, so in our minds, we're thinking, you don't have to write this down anywhere, but in our minds, we're thinking that, okay, 7 minus 6, this is about 1, right? It's a little bit smaller than 1, because pi is a little bit bigger than 3, and this is 10 minus 6, so it's about 4. So our minimum is going to be this. And what I would write is, I would just write that the minimum is 7 minus 2 pi at x equals 2. That way you're getting both the y value and the x value, and you can't really get it wrong. If you wanted to write it as a point, you could also write it as f of 2 equals 7 minus 2 pi. Either way, right, would have been fine. But writing both the x and the y kind of gets you a fail-safe way of doing that. The justify here, by the way, we don't have to write any new words. The justifying was the table. Right, and then last one, D. For each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So this one's a little bit tricky, especially the second one, but it's not too bad. So what we need to make sure we're realizing is that if I want f double prime of x, how does that relate to f prime, right? So f double prime of x is essentially the derivative of f prime of x. So in other words, it's the slope of our graph f prime of x. So at -5, right, -5 is right here, so -5 is part of a line, so this one's pretty easy. When it's part of a line, this is what I was showing in the last example where we just take our endpoints and do y2 minus y1 over x2 minus x1. So for f double prime of -5, we would just write 0 minus 2 over -2 minus -6 And that gives us negative 2 over 4, which is negative half, right? Y2 minus Y1 over X2 minus X1. Now for F double prime at 3, this one's a little bit trickier, because at 3, it's at a kink at a corner. So I'm going to show you guys what I would probably do on the AP test, but then I'm also going to show you guys kind of maybe even a step further if you really want to make sure you get the point. So obviously it's DNE because it's a kink, so I would probably just write DNE because, okay. So I would probably write it's DNE because F prime is not differentiable at x equals 3 because the graph has a corner. And I think you would get the points for that. That's something where you're technically correct. Now, if we want to take it a little bit further than that, we can kind of say that the limit as x approaches 3 from the left side, and do y2 minus y1 over x2 minus x1. So, essentially it's just, would be, so the left side would be this left part of the graph. So the y2 is, or the first point is 3 comma 2. The other point here is 2, 0. So 2 minus 0 over 3 minus 2. And so we get 2 over 1, so we get 2. And then we can do, after that, we can do the right side. So we can do the limit as x approaches 3 from the right side. And then for our right side, we would have 3 comma 2 and 5, 0 for this right side. So 2 minus 0 over 3 minus 5. And we get 2 over negative 2, so we get negative 1. So now what we can kind of say because of this is that f double prime of 3 does not exist because, right, 2 is not equal to negative 1, and that's okay because you showed your work over here. That this was essentially the left side of the derivative limit and the right side of the derivative limit. So I don't think you would have to do that, but it's just showing you kind of a step further. If you really, really wanted to prove it, that's how you'd prove it. But from everything I've been told by readers and graders is that if you just explain this part, you'll be fine. So that's kind of our notes portion of this. Our homework tonight is going to be 3 more questions like this. Unfortunately, today I have to go down to Vaughn to pick up some stuff for some of these, basically like trying to get the teachers ready. So I'm not going to be able to stay and work out the homework with you guys. But what I will do is, if there are questions that are really tough for you, just post them, and I'll either make a video or write out my work. I will still write out my work because I know sometimes the answer keys are a little bit different. So I'll write out my work on paper and post that as well in addition to the answers. So you guys can kind of work through that. And if you have questions or if one of them is just really, really hard for everyone, I can make a short video doing that question. Sound good? So thanks again, guys, for coming, and I'll see you guys tomorrow. Oh, and don't forget, tomorrow we're going to do that Zoom, right? We're going to download Zoom.